I'm all right. Yeah, I don't feel good. Folks, here we go. So we already know that in similarity, if two figures are similar, whether it's triangles or polygons, that the angles have to be congruent. All right, similar polygons. In order to have them, you have to have corresponding angles congruent, and corresponding sides are what? Proportional, okay? Now, just so you know, you're not going to get water when you, good, okay. Pardon me? I know, milk's the only thing that helps, dairy. Because of the something about the enzymes in dairy products kills the burn in anything hot. I know it's recording. I don't care. What? What? It's okay. For real? Okay. No, thank you. I just know that dairy kills the burn, whether it's milk or. I don't know, Kevin. I'm sorry.
It's going to burn something else. Well, it does whether you drink it or not.
That's what somebody told me. Thanks, Dennis, for sharing. All right, so here we go, guys. So on similar polygons, corresponding angles are congruent, corresponding sides have to be proportional. Now, if you look, we're given angle-angle similarity, so those two angles have to be congruent. We're given side-side-side, which means all three sets of sides have to be proportional, and side-angle-side means that two sides in the included angle, the two sides have to be proportional, the included angles have to be congruent, okay? Now, look at what we're given in number 1. What are we given? What type of information are we given? Are we given side information or angle information? Angle. It appears that if these two figures are similar, that they're going to be similar by which of these 3 theorems? It appears that they would be similar by angle-angle similarity. Now, how can I ensure that they are? Work it out. What do you mean, work it out? Fill in the missing angles. How do I do that? If I take 180 minus 92 and 49, folks, y'all have got calculators. I don't. What is 180 minus 92 minus 49? 39. One more, 39? Okay. So angle S is 39 degrees. Hey, is that going to work? Yes, so that means that angle U has to be what? It has to be who? It has to be 49 degrees. So do I have 2 congruent angles? Yes. I have a 92 degree angle congruent with a 92 degree angle. Angle Q is congruent to angle T. I also know that angle R is congruent to angle who? U. Now, could I have marked S and V? Sure, I could have marked S and V. Which question? Because I could do the same thing. I could come over here and I could say 180, take away 39, take away 92, and it would have given me 49. Okay? All right, now, with that information, it says, explain how you know the triangles are similar, write a similarity statement. First of all, we've proven that two angles are congruent, yes? We know that angle Q is congruent to angle who? T. And we know that angle R is congruent to angle who? U. So are these two triangles similar, yes or no? Yes. By what theorem? Angle-angle similarity. And you got to have that little squiggle mark there. Now you got to come up with a similarity statement. So it's going to be triangle what? Somebody, Michael, get us started. Triangle what? This is the part you can never get wrong. You always want to be on the first part of this. Triangle what? You name the first triangle. RQS. If Michael starts with triangle RQS, then Kale, we have to complete that similarity statement with, now be sure your letters match up, corresponding letters. Triangle who? U, T, V. 2 marks, 1 mark, no marks. Very good. Does that make sense, yes or no? Yeah. All right, look at the second example. Is there anything up there that I can mark? That I have the right? Ooh, vertical, that's universal sign for vertical angles. So mark the vertical angles. Even though they're not marked, you have the right to mark those. Now, it appears that if these two triangles are similar, they're going to be similar by what? Side, angle, side. That's what it appears. Look at it. Side, angle, side. Do you guys see that? All right, so let's try. It appears that we're going to be able to use side, angle, side similarity. Are my two angles congruent? Well, yeah, they're congruent because of vertical angles, right? What do I have to check about the sides? I've got to see if my sides are proportional. Now, here's what you need to do. We've got to figure out 18, folks. 18 is going to correspond to 27. It goes across, okay? It goes across. This is the weird thing about similarity that I don't like. And usually it's not, you wouldn't see this on an SOL. But if I reduce that fraction, 18 over 27 can be reduced by what number? Go bigger. Pardon me? It goes to 2/3. Even if you didn't know, you could put that in your calculator, 18 divided by 27, hit math frac, and it'll give you the correct fraction. Hit your math button, and then hit enter. Enter, okay? That will reduce fractions for you, okay? Pardon me? Now we have to check what? I got to check the second proportion. 16 divided by who? 24. We want it to become what? We want it to end up being 2/3. When you reduce 16 24ths, is it? Yeah, okay. All right, we got good things going on. We got 2 sets of corresponding proportional sides. I know that vertical angles are congruent. Are we correct in assuming that these two triangles are similar by side, angle, side? Let me say that again. Am I correct in assuming that these two triangles are similar by side, angle, side similarity? Yeah, they are. All right, now you got to be careful here. Who's going to start it? Who's going to start the triangle? All right, go, Kevin. HGJ. This is the tricky part, Daniel. Very good. LKJ. By side, angle, side similarity. Comprende? It would have not been in the right order. Remember, you got to have the corresponding sides matched up properly. H corresponds to L. G corresponds to K. Okay. HGJ, LKJ. Here, vertical angles are congruent. Yeah. Questions at all? Is this making better sense to you? And I'm going to tell you, if this is making better sense to you, then well, how about triangle congruence? Would you be able to pick out side angle side incongruence now? Would you be able to pick out side side side? I would hope so. But is the angle available in triangle congruence or just triangle similarity? Just similarity. Just similarity. That's all right. I know what you're saying. What about this one? What do you think? Does it appear to be similar by? Side, side, side. It appears. So, Cody, what am I going to do to check it? You're right. It appears to be similar by side, side, side similarity. Absolutely, you're correct.
You measure like the 15 and 12.
Oh, 15 over 12? 15 over 12 because there's two sets of those, right? Do I have to figure that twice? No. Nah, we don't even need to do that. That'll be twice. We got to figure that one twice. And then if I go 15 over 12, 10 over 8. You could go 12 over 15. All right, what's 15 over 12? Hold that thought. 5/4. Okay. Check your other. So we went 10 over 8. Did you go 8 over 10? Because you should. You have to go in the same order. What's 10/8, y'all? It's 5/4 again, isn't it? So do my proportions, do my ratios match? Yes. Cody, are they similar? Yes or no? Yeah, they are similar. Pardon me? Yeah, Brandon, it was okay for you to put 12 over 15 as long as you've listed 8 over 10. Why? Because you have to go, like, Amber, you got to go in the same order. No, not if you go 15 over 12. If you go 12 over 15, then you better go 8 over 10. Did you get 4/5 twice? Then you're okay because your ratios match. You understand? As long as your ratios match, that's all that matters. Are these two triangles similar? Yes or no? Yes. All right, here we go. Similarity. Similarity statement. Somebody get me started. ACB. Somebody finish that. MPN by side, side, side similarity. How many of you got it? Makes sense. Questions at all? No? Corresponding angles have to be what? Congruent. Corresponding sides have to be proportional. Let's keep moving. Oh, are we done? Oh, there we go. That was kind of, you sounded like you were excited. You were ready to do number 4. Of course you were. Let's try 4. What does it appear to be? Side angle side. You're thinking that it's going to be side angle side. Vertical angles, good. And it looks like a bow tie. But it says explain why the triangles are similar and then find each length. What segment do you have to find? I don't really need to find JK. What? KG. How am I going to find KG, Dennis? I'm going to call it my X. If they're similar, how? Set it up. X over 11. All right, now if he goes in that order, X over 11, then you have to go in 8 over 12. Good, y'all. Oh, Lord, how am I going to solve? Cross multiply. Kevin's like, what the crap? Do it. Do this problem. It's all right. 12x is equal to 88. Did you divide both sides by 12? 7.3 repeating? Okay. He said that. Did he say that? He said that. He totally said that. Attaboy. He said that. 22/3. He's already said that. He so said that. I'm glad you said that. Yeah. Questions? Is 7.3 repeating okay? It's all right. Whatever. Yes. Why? Because it is actually what? What fraction is 0.3 repeating? Yeah. He said that. It's isn't it 0.3 repeating 1/3? And 0.6 repeating is what? Y'all should know this. No. 0.3 repeating is 1/3. Put in your calculator 1 divided by 3 and see what you get. Ah, that's what I said, right? Now put 2/3 in your calculator and tell me what you're going to get. 0.6 repeating. Y'all should know those. You have to. What about the 7? What about the 7? Where are you talking about? Here? Oh, because the calculator has to round it. So it's rounding it up. That's all. Right? Isn't that what you said? That's what I thought. That's what I thought you said. All right. What are we figuring for this one? Look at this. Oh, this is so easy. It is. Yes, it is. What? It is kind of big, but no, I can't assume that both sides are 28. Say it again.
4/26 or 42/26, and then x over 26 or 28.
No. If 42 is from the big triangle, let's name these. Hold on. Write this down. If you had to name the big triangle, how would you name the big triangle? TSU. TSU. Do you guys agree with that? All right, so if we name the big triangle TSU, then what are you going to name the little triangle? WV. Okay. Do they have anything in common? The U. All right, so if they have angle U in common, then what do you know about angle U? Oh, somebody say it again. Why are they congruent? I know you did. Claim it. Exactly. Why? They share the same angle, folks. What property says something is congruent to itself? The reflexive property. Very good. Claim it, Justin. Very good. That is exactly right. Now, back up and look at that picture now. Are those two triangles similar to one another? Are they similar by, excuse me, the St. Ryan's Buffet? Here we go. So I can tell you tearing up his problem rather than Cheetos. Are these two triangles similar by angle-angle similarity, side-side-side similarity, or side-angle-side similarity? What's the best answer? Why, Dennis? Why is it angle similarity? It's got two sets of corresponding angles congruent, doesn't it? What's the first set of corresponding congruent angles? Angle S is congruent to angle V. That's given. What's the other set of congruent angles? Nope. Angle U is congruent to angle UY. The reflexive property of congruence kind of like a proof. Ain't that something? Don't we love them? So that means that triangle, you start it. Well, we already have it. TSU is similar to triangle WVU by what? Angle similarity. Folks, does it make sense? Not that one? You know what you would have missed? No. You would have tried to find a side measure, right? Okay? But back up and look at the big picture. Okay? Back up and look at the big picture. Is there something that we can mark congruent to itself? Remember, I always in the bow tie, you guys are now conditioned that you like automatically vertical angles, and you do that number. What do you need to mark? And y'all do this, which means vertical angles. But when you see a triangle within another triangle, you got to think. All right, hold up. It's two triangles, but they share an angle, don't they? Okay. They absolutely share angle U.
But what if it didn't share?
Then they wouldn't be. It wouldn't be one inside the other,
So they have to,
or it'd be a jacked up problem, and we wouldn't do it.
so they have to share an angle to be.
No, not necessarily, because it could look like this. Don't write this down, but just
Daily Star.
yeah, that's what it could look like.
How would you
Yeah.
solve something like that?
It would. Very carefully. You would have to be given side information to do that. Okay. Any questions at all? All right, let's look at this. All right, look at what it says. Explain why those two triangles are similar, then find BC.
What do you call it? Yeah, mid-segment.
All right, Smarty McFarties. I'm impressed that you remember that.
Was it right there?
I don't know.
Because you can time.
Ty, if you can prove it to me, then I'll buy it. But you got to prove it on paper. Look at the. You have to do two things. Number one, you've got to explain why those two triangles are similar to each other. And it's either going to be angle similarity, side similarity, side similarity. It's either going to be one of the two.
We just did one side.
Then you've got to find BC. Go. Do it. You need to remember, just for a guide, I would use little triangle to big triangle. Just saying. I could use big triangle to little triangle, just as long as you keep it in the same order. Okay? See what you can do with that. All right, that's awesome. You must have all this completed because you're talking. Little. What's one of the sides for the little? 2. 2. Okay. I could use 2. If I use side AE, then what's the whole side for the big triangle? Ooh, how'd you get 4? 2 is 4. Now, I got to find X. So what number do I use next?
3.
3.5. Why? Because it corresponds to X, right? Do you guys agree with that? Great. Solve. 2x is equal to, is it 14? Did you get 7?
I didn't do it like that, but I got.
I mean, I got it right.
I did 3.5 times 2.
That's what
Oh, why did you do 3.5 times 2?
the mid segment. That's what I did. But you still get the same answer.
But you still at 7.
That's exactly what I did. So if it's good both ways, I'll let it.
I want you to put on there my way, and that's what I want to look at. Okay. Well, we got to look. Did you go? All right, so let's check this out. You're right. I'm thinking, Carson, did you go? 3 over 6 is equal to 3.5 over x. 3x is equal to 1821. Wait, 6 times 3.5, that's 18 and 3. That's 21. Put your calculator, 6 times 3.5. Okay. When you divide by 3, you still get 7. Excuse me. You still get points, or you still get 7. So either way, it should work out correctly. Okay? Folks, why are these two triangles similar to one another? Why, Amber? Because of the angle in the triangle. That is exactly right. They share the same angle. It goes back to the last problem we just got finished doing. These two triangles are similar by side angle, side similarity. You're exactly correct. Okay? And because of that, we are able to find x. And you guys are figuring out that there's more than one way to skin a cat, aren't you? Okay? Some of you, how many of you use the mid-segment theorem? Hold up, hands up. Hold up your hands. How many of you used similarity proportions? Raise your hands. That's cool, folks. I don't care how you solve them as long as you get them right in the end, okay? As long as you get them right in the end. Let's look at the next one. Shut the front door. Yes. Lord, let's see. Get your homework. Get your books out. Lauren, you acted like... That's what I would do. I would use that picture 3 times. And I would draw it 3 times. Okay? Because clearly, JK is going to correspond to what side over here? MN. KL is going to clearly correspond to NP. And the base JL is going to correspond to MP, Mary Papa, right? Mary Poppins. Had a girl. You understand what you need to do? You got 4 problems. I want this done in 15. Okay, so that's number 10. Because these pieces right here are not the same, that's why you cannot use mid-segment this time. That's why some of you did last time and it worked. If these 2 pieces right here, Brandon, were the same, if this was 586 and this was 586, and this was 644 and this was 644, absolutely you could use mid-segment. And that would have been the easiest way to solve it. But watch. You know they're similar triangles. You know they are. Check this out. Because it's one triangle inside of another. Does that make any sense? What did I just mark up? What did I just show you, though? What do I always use? And Amber always says, she says, use it as your guide. What am I going to use as my guide? I'm going to use little triangle over big triangle. Now, use that as your guide. What's the little side that I just marked? 586. What's the big side? How in the world did you get 13 blah, 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 blah? You just said. 586 plus 733 is 1319. Okay? That's it. Now it's got to be set equal to 530. Why? Why not one of these numbers down here? Because I'm trying to find this right here. No. Because. Oh, wait a minute. Are you saying, would I have been able to use 644 over 1444 is equal to 533 over x?
Or you got 644.
It is. Let me see your paper. That's what you got. 644 over 800. Hold up. You got a little mistake. Because it's not over 800. It's got to be over 1444. Because when you add them together. Now, if you would have had 1444, absolutely you could have done that. Okay? Doesn't matter which side. As long as you have 533 over x, then we're good to go. Because 533 is from the little triangle, x is from the big triangle, okay? Cross multiply, your numbers are huge. 586x is equal to 1319 times 533 is 703027. Divide both sides by 586. And it said, pardon me, it said to round to the nearest meter, correct? And when you do that, you're going to get 1199 point something. 1199.7 blah, blah, blah. But it said to round to the nearest meter, which makes 1,200 meters. And I said, I don't care about the kilometers. I don't give a rat's hind end about that. But how many of you did have 1,200 meters? Very good. Very good. Folks, you've got to get this. We're getting ready to hit this section where we're doing these types of problems, and you better figure it out. You better figure it out. If that means you got to mark up with different colors, then you got markers back there to do it. Okay? Look at 20, 21 and 22. Number 20, were those two triangles similar, yes or no? Yes. By what postulate or theorem? Side angle, side similarity. That's what you should have figured out. And if you don't figure out, excuse me. Oh. What do we have? JKL? Did I have it something like this? And it is an MNP? And number 20 said, this will help you. 20 said K is congruent to N. And then it has JK over MN. Oh, they definitely correspond. JKKJ. Okay. Is equal to KL over NP. Folks, I don't care that I don't have numbers. What is marked here? Side, angle, side. So they are similar by side, angle, side similarity. Okay? That's what you had to do. That's what you had to do. Number 21. Hey, what are you given? You're given 3 sets of sides. Side, side, side similarity. Okay? And then number 22, look at this one. Oh, be careful now. Be careful. Do we know a side-side angle? Because that's just backwards. Is it JKL? MNP? Okay. Did I put it in the right order? All right, look at it. J and M are congruent. That's cool. Got that. JL over what? MP, Mama, Papa. All right, so far so good, right? Look at the next one. KL over who? M. Oh. Okay, look at it. Start at one place or the other. If I started here, it would be side, side, angle. If I started here, it would have been something we don't say. There is no theorem. There is no postulate that is called the postulate. We put the squiggle in the line. Yes. Why? Because they're not similar to each other. And if you put y, you would put, nobody in their right mind would call a postulate or theorem the theorem for 14, 15, and 16-year-olds. They could not do that. Unless it was a 13, 14, 15, or 16-year-old. Yes, you're right. They are not similar to one another, right? Questions? What are you going to do? Right now, I want you to look at 23. We're going to do that one together. Draw this in your book. Don't draw this in your book. Draw it on your paper. Holy moly. Oh, it's just sides. The three pairs of corresponding sides are all proportional. Therefore, why would I not mark them with tick marks? Because that would make me think congruent. Let me show you what I would do. I would do it with colors, though. And you know how you mark the sides? That's what I do.
Don't they share an angle there?
We'll just make a squiggle with it. I mean, a bullet point, bullet point. Do a box here, squiggle, squiggle. So you can see that the corresponding sides all pair up, okay? All right, so let's look at this. We have these two angles that are congruent. And if you heard my conversation, I would not mark anything with tick marks because it makes me think that they're congruent, okay? Again, what am I going to use as my guide? Little over big. That's my guide. Okay? Little. 3 corresponds to, be careful here. Oh. Is it 3x? Is it 3 times x? It's 3 plus x. This is got like a problem on steroids, folks, okay? But you may see this. And look, changing colors. What's my other little side that I'm given? 4, good. Over who? X plus 5, good. Bless you. Can we solve that? Yeah. Heck yes, that's algebra. No. We got to distribute. Let's do this one together. Distribute. 3 times x is 3x. 3 times 5 is 15. 4 times 3 is 12. 4 times x is 4x, right on? Okay. I'm going to subtract 3x because I don't like to have a negative variable. You can subtract 4x if you want to. I don't care. Just as long as we get the same answer in the end. How about them apples? Is that facile or difficile? Facile because solving that equation is easy. What's the most difficult part of that problem? Do it by yourself. You're going to do the next one by yourself. Thank you for mentioning that. Distributing? No way. Setting it up. Because what do you think could be a common mistake? That 3 plus x thing. That is added. Okay? It's not 3 times x. It's 3 plus x. Look at the next one. Look at the next one. Folks, and if I ever leave you, you got to watch this video at home, okay? 2x minus 2. X plus 9. 20 and 15. All right, what does this look like? This looks like our what example? Looks like a bow tie. All right, so Joseph, let me just ask you. 2x minus 2 is going to correspond to what? There we go. Go across. Go across. And it's going to be equal to, oh, looky there, looky there. There we go. Solve it. Solve it, y'all. Go on. Make sure you got it set up right. Do you have 20 times 2x minus 2 is equal to 15 times x plus 9? Do you have that line right? Do you have 40x minus 40 is equal to 15x plus 135? Yes? Okay. Did you subtract 15 from both sides? Did you subtract 40 from? All right, so then you would have gotten 40x is equal to 15x plus 175. Did you subtract 15 from both sides? Ding, 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 ding. Just found your mistake. Fix it. Don't divide, subtract.
I got it.
You added 40 to both sides. I got a minus 42. Okay, Justin? Don't do that. Don't do that. How many of you got 7? Sure enough, hands up. Do you have questions? So, did you get that? Did you set it up correctly? Do you know where you went wrong? Find your mistake. Here's the thing, folks. You do not need to leave your examples wrong in your notes. Don't do it. Find it and fix it. Okay. Did you subtract 135 and then subtract 40? Because you could have done that. Oh, there you go. You move things around. Okay? Fix it. Don't have it wrong in your notes. I don't ever want any administrator to roll up in this classroom and say, give me your notes. And then they look at, because look, Miss Clark, yeah, they can do that. Why not? Miss Clark's a math teacher. She could totally say, well, that problem is wrong. And then you could say, what's what Miss Perry had on the board? And she could look at it and go, well, it ain't right. She ain't teaching it right. Oh, you would throw somebody else under the bus. That a girl. Hey, no, the thing is, folks, you need your notes correct because I know you guys go home and study all the time. Look at y'all. Your faces tell me the truth every day. Some of you did this when I looked at you. You study every day, and y'all went. Immediately looked away. Liars. At least you won't make eye contact and lie. Liars. Here we go.
Do I have to share the screen still, or can we just do it?
You can just do it, but you better get it right. You better get it right.